Hello everyone, this is Mrs. Pagan, and in today's lesson we will be talking about the properties of exponents. Now before we get into the 7 properties of exponents, let's go ahead and do a quick vocabulary lesson. Let's say that I have 2 to the 6th power. I want you to know that the 2 in this case is known as the base, and the 6 in this case is known as either the power, or it can also be known as the exponent. So if you hear me say the base, I'm talking about the number right here. And if you hear me say the power or the exponent, I am talking about the smaller number that is in the right corner of the base. Alright, let's go ahead and get started on the first property of exponents. The first property of exponents is called the product of powers. And the way, according to the definition, is a to the m power times a to the n power is the same as a to the m plus n power. So an example of that would be if we ended up having x to the third times x to the fifth. One way we can simplify this further is by just adding the exponents, keeping the base the same, which is x, and adding 3 plus 5, resulting in x to the 8th. Now, we would never show the literal step of adding the exponents. We would eventually just get to the final answer. Okay? Great job. So just to keep ourselves, taking notes, what I tend to do is add exponents. Just a quick reminder that if I see an example like the one above, then I know to add the exponents. Alright, let's go ahead and go into the second rule, which is power of a power. It kind of looks like this: a to the m power raised to the power of n. And in that case, what we can do is take the same base and multiply the exponents. So an example of this would be p to the second power raised to the third power is the same thing as p times 2 times 3. Which is the same thing as p to the 6th power. So to remind myself of the rule, when I see something similar as this example, I know that I would have to multiply the exponents. Alright, well done. Let's go into the third property of exponents, which is the power of a product. Power of a product looks like this. Let's imagine that we have 2 bases, a times b raised to the m power. In that case, what we do is distribute the power of m to both of the bases, ending up with a to the m times b to the m. An example of this would be if I had j times k raised to the 4th power. What I would want to do and have to do by this property is give the power of 4 to the j, allowing it to be j to the 4th power, and also to the k, allowing it to be k to the 4th power. Since j and k are not the same base, I can't go any further, so I would stop the problem right here. So in problems like these, what we tend to do is distribute the exponent. Alright, well done. We're almost halfway through, so let's keep going to the 4th property of exponents, which is called a negative exponent. Now, the negative exponent is an example of a to the negative m power. Well, the problem is we do not want a negative exponent, so what we do is switch its location. Since the base with the exponent is in the numerator, we're going to go ahead and drop it down to the denominator. When we switch it, the sign changes to a positive. Obviously, we need to have something on top, so we'll put 1 so it doesn't look very awkward. So here's 2 examples to kind of explain the situation. V to the negative 6th power. Well, since that's in the numerator, we're going to go ahead and move it to the denominator, making the exponent negative 6 to a positive 6. Obviously, putting a 1 on top so it doesn't look empty. Now, you can also run into a situation where the negative exponent is in the denominator. For example, in this case. Well, in that case, we're going to go ahead and move its location to the top, making sure that x to the third is now positive. It's over 1, but most of us don't even write over 1. We just write x to the third. So a note to myself in these types of problems is to change location. If it's on the top, move it to the bottom. Change the exponent from negative to positive. And if it's in the bottom, like in this one, move it to the top and change the exponent to positive. Well done. All right, let's go into the fifth property, which is called the zero exponent. This is one of my favorites. It's a to the 0 power equals 1. As a matter of fact, an example would be f to the 0 power equals 1. Another example would be t to the 0 power equals 1. Anything to the 0 power is equal to the answer 1. All right, well done. We have our last two that we're going to go into. So the sixth property is the quotient of powers, which is, quotient means division, just remember that, a to the m divided by a to the n. And in this case, what we do is we subtract the exponents. So those are equal expressions. So an example of this would be y to the fifth divided by y to the fourth equals y to the fifth minus 4, which is equal to y to the 1. So that would be one answer that we can have. Now, we can also have another one. I'm going to kind of go into the other one. I apologize for that. So it would be y to the 9 divided by y to the 11 would be y to the 9 minus 11, which you know to be a negative exponent, and y to the negative 2. Now, remember that we don't like negative exponents, so I would actually continue with this problem if I was simplifying completely. Right now, I'm just kind of showing you how to use the quotient of a power. So there could be times where you're going to have to use two of these rules to make sure that it's in a way that mathematicians would agree and enjoy and like, okay? So, but in this quotient of powers property, what we tend to do is subtract the exponents. I'm going to change my color back. So we subtract the exponents. Okay, and sometimes we can get positive exponents, sometimes we can get negative exponents, and this kind of goes with all of these rules. But when it's negative, we have to change its location. Don't forget that. All right, let's go into the last property that we have, which is a power of a quotient. And here's what it looks like. We have a base a divided by b raised to the power of m. In that case, we can go ahead and distribute each one with the power a to the m divided by b to the m. And an example of this would be t divided by v to the 10th power is the same thing as t to the 10th power divided by v to the 10th power. And just to keep ourselves writing these small notes, in this case what we did is once again distribute the exponent. Alright, well those are the 7 properties that we have. I do want to give you one last tip. Eventually we're going to be combining these properties, and the only thing that I want you to remember is for an algebraic expression to be simplified, underline that, there are only positive exponents and each variable only appears once. So double check these two things when you're solving problems as we get into harder things. So great job today with the 7 properties of exponents. Go ahead to the tables to work on your in-class practice, practicing these 7 properties. See you later. Bye.